Ever wondered how data is transferred from one device to another? It all starts with a MAC address. Now, you may be asking yourself, what is a MAC address? Well, let's dive right in. A MAC address, or Media Access Control Address, is a unique identifier that is assigned to network interfaces. This could be your computer, your smartphone, or even your smart fridge. This identifier is used for communication at the data link layer of a network segment. In simpler terms, the MAC address is the unique name tag your device wears in the vast digital playground. You see, when devices communicate over networks like Ethernet and Wi-Fi, which are based on IEEE 802 network technologies, they don't recognize each other by the device names we give them. Instead, they use these MAC addresses to identify and communicate with each other. Think of it like this. Imagine you're at a party where everyone is wearing a name tag. You wouldn't call out to someone by describing their appearance or what they were wearing. No, you'd call them by the name on their tag. Similarly, in the world of network communication, the MAC address is that name tag. This unique identifier ensures that the data sent from one device reaches the correct destination. Without it, your data would be lost in the digital wilderness, struggling to find its way home. So the MAC address serves as a unique identifier to ensure your data reaches the right destination. Now that we know how data finds its way, it's time to understand how it navigates through the network. Enter switches and bridges. Just like the traffic signals in our cities, switches and bridges play a pivotal role in managing the traffic within a network. They are the unsung heroes that ensure your data doesn't get lost in the labyrinth of the network. Let's start with switches. These ingenious devices connect multiple devices on a network, be it your home or office. Every time you send an email or stream a video, the switch steps in. It reads the MAC address of the data packet and directs it to the correct destination. No more getting lost in the network maze. Bridges, on the other hand, are a bit old school. They connect different segments of a network. Their job is similar to switches, but they handle traffic differently. While a switch directs traffic based on the MAC address, a bridge uses a process called bridging. This involves reading the MAC address and then deciding which segment of the network the data should go to. But here's the catch. Bridges can only handle a limited amount of traffic. Switches, on the other hand, are designed to handle a much larger volume. It's like comparing a small-town traffic cop with a big city traffic control center. Switches and bridges, in essence, act as traffic managers, efficiently directing data in a network. With all these data zipping around, there must be a way to organize it, right? That's where VLANs come in. The beauty of a network is not just in its ability to connect devices, but also in the way it organizes these connections. To make sense of it all, we employ a system known as Virtual Local Area Networks, or VLANs. A VLAN is essentially a network within a network. It's a logical rather than physical grouping of network devices that can help us manage our network more efficiently. Think of VLANs as creating virtual neighborhoods within a city. Each neighborhood can have its own rules, and only authorized residents can access the resources within that neighborhood. Similarly, in a network, VLANs group together devices based on logical functions, departments, or even applications, regardless of their physical location in the network. But how does this help us? Well, imagine a network without VLANs. It's like a city without any zoning laws. A factory could be next to a school, causing unnecessary noise and disruption. Similarly, without VLANs, all devices would be in the same broadcast domain, leading to a lot of unnecessary traffic and potential security risks. With VLANs, we segregate the network. Each VLAN forms its own broadcast domain, which means that only devices within the same VLAN can communicate directly. This reduces unnecessary network traffic, making the network more efficient. Plus, it adds an extra layer of security, as devices from different VLANs cannot communicate directly. Moreover, VLANs aren't restricted to a single switch. They can span across multiple switches, creating even larger logical networks. This flexibility allows network administrators to group together devices as per their needs, without being restricted by their physical location. So, VLANs are like the zoning authorities of a network, keeping everything in its correct place. They ensure the network is organized, efficient, and secure, making them a key component of modern network design.